Okay, so we're going to be doing the Kell blood group. Now the Kell blood group is kind of larger, like more information within itself. So I'll do one on the Kell blood group and then do a video on the other blood group systems. But I wanted y'all's opinion. What would y'all think about like individual 5-minute videos for each one of them instead of one long other blood group system video?
That'd be pretty good, so it'd be easy to differentiate.
So I would just have like, 10 small videos instead of one large one. And then that way you could watch them in shorter intervals, like on breaks and stuff.
Yeah.
Sound good?
Sounds good.
And I'm going to try to make some that are like quickie videos. Jasper said it helps when they're shorter, not having like an hour to 3 hour long video, to just have a bunch of little short ones. So I think I'll try to make some for the main ideas in blood bank too, like maybe just the antigen antibody and like the Weiner terminology, like the R1s and R2s and RYZs. So I'm going to try to make some smaller videos for a bunch of these. So your Kell blood group consists of a big K, and then this one's called Kell. And then there's also a little K, and this little K is called Cellano. Cellano. So now less than 9% of the population are positive for Kell, and greater than 90% of the population are positive for Cellano. They are inherited as co-dominant alleles. And they are what is considered anti-helical partners. So which just means that they are a product of allelic genes. And you'll understand more as you go into more blood group systems as well. But the main thing to know is that Kell and Cellano are antithetical partners. They are well developed at birth. So Kell, then what's the sign for Kell? Is it the big K or little K?
Big K.
Big K.
Yep. So Kell's your big K. Is very immunogenic. Which one is most immunogenic out of the blood group systems? What is the most immunogenic blood group antigen?
Yeah, could you give us an example or give us choices?
Yep. It is so like in your RH system, you've got D, C, and E. In Kell, you've got Kell and Cellano. In ABO, you have A, B, or O. I'll give you a hint. It's in the Rh blood group system.
Mhm.
The most immunogenic.
Was it
But Lily?
the antigen?
Yes. So the
Mm.
most immunogenic is your D antigen in the Rh system, and second to D is going to be your Kell as far as immunogenicity.
So in Kell, it's the D2?
No, I'm just saying that Kell is immunogenic like D. Your D antigen is extremely immunogenic, which means it'll cause, like, you know how your HDFN, your hemolytic disease of the fetus and newborn, is worse if you have a D incompatibility than if you have an ABO incompatibility. That's because D is more immunogenic than ABO. So your Kell
Okay.
is second to that D, immunogenicity wise. So it's not in the same system. It's not the same in that aspect. They don't go together. But immunogenicity wise, Kell is second.
Okay.
So D's most immunogenic and Kell's second most immunogenic. So there's some other partners, and they're also antithetical partners. In the Kell system, and they are going to be KPA and KPB. And then the next one's going to be JSA. And JSB. And then to remember which one's high frequency. So you know how up here we talked about Kell being less than 90% of the population positive, and then your greater than 90% of the population are positive for Cellano or little k. To remember which one of these have are high incidence or high frequency, it's the B ones. So B meaning not for everything, just for this Kell group. So out of KPA and KPB has a higher frequency or incidence rate than KPA, and JSB has a higher frequency than JSA, which means people are more likely to have the KPB or JSB than they are to have KPA or JSA. There are 32 antigens in Kell system. And they react with disulfide bond. Their disulfide bond regions react with the reagents. So the reagents bind with disulfide bond regions. So their reagents are 2Me, DTT, AET. So these are the reagents they react well with. And Michelle, I'm writing out the names so you can see what the names stand for, but I don't think you'll ever have to remember the name.
All right.
Like if you ever got asked anything about it on a test, it would put the 2-ME, DTT, or AET, never the full name out. Ithiopurietol. And 2-amino ethylene. That is a mouthful, isn't it? So much.
Okay.
And then your K0. K null. Or K0, K0. What do you think is special about them?
They're the lowest.
They're going to lack all system antigens. So they won't have any of the Kell system antigens.
So they won't have any Kell in them.
Exactly. So you know how it says right here that there's 32 antigens in the Kell system? They don't have a single one.
Okay.
Not Kell, not Cellano, not KPA, not KPB, not JSA, not JSP, and then any of the others either. Now, Kell antibodies. Where's Kell antigens going to be on?
Blood cells.
Yep, on the red blood cells. So these are going to be our Kell antibodies. Do you know what immunoglobulin they are? They're immunogenic and clinically significant. So what immunoglobulin are they? IgG or IgM? Which is
IgM.
clinically significant?
IgG.
Exactly. Yep. So they're IgG. With an exception that naturally occurring IgM are rare and caused by a bacterial infection. Specifically by that E. coli 0125 B something or other, B15 or something like that. And so a specific E. coli infection, strain of E. coli, can cause a naturally occurring IgM Kell antibody, but that's like super rare. So if you ever get asked a question, it's IgG. So it reacts at the antiglobulin phase. So this means that the most reliable or the best results are going to be with an IAT. And then PEG may enhance as well, enhance the reaction. Now your Kell antibodies, they do not bind complement. They are involved in HPRs and HDFN. And what do those stand for? Which HPRs?
Hemolytic transfusion reaction.
Exactly, yep. And then what's HDFN?
Is that the mother and child? Oh, I'm wrong.
Huh? Hemolytic disease of the fetus and newborn. You're on the right.
Oh, so I was on the right track.
And so the hemolytic transfusion reactions and the HDFN go hand in hand with their either red blood cell stimulated or pregnancy. So let me write these out with hemolytic transfusion reaction and HDFN. So hemolytic transfusion reaction is going to be your red blood cell stimulated, RBC stimulated during a transfusion. And then your HDFN, hemolytic disease of the fetus and newborn, will be RBC stimulated through pregnancy. Next one I'm going to talk about is KX. Now, KX antigen is present on all red blood cells, with an exception. Do y'all know the exception? Well, I guess y'all haven't gone over this yet, so you don't. So, except people with a McLeod phenotype, which leads to McLeod syndrome. And that usually ends up as a test question also, that McLeod phenotype. So this McLeod phenotype or syndrome is X-linked. What does that mean?
Sex. Chromosome.
Yep, your sex chromosome. And you often find people with a McLeod phenotype. They have hemolytic anemia. With an increased acanthocytosis. They're also going to have an increased creatinine kinase. And then it's often associated with chronic granulomatosis disease. Y'all just can't get away from this, can you? So what is it?
Is it that one thing that with what blood cells, like creating a barrier or something, white blood cells or something?
Yep. Yeah, so what happens is your white cells will phagocytize the invader, but they can't apoptose. And so it's just a buildup of white cells, and it can block organs and other such things. So they lack the ability to apoptose. You'll also see neurologic and muscular abnormalities or defects.
The ability to what?
Oh, they can't apoptose.
I can't hear that word you're saying.
I'm gonna send it to you in the chat. Maybe. Oh, I can type it right here. I'm silly. WBCs can't apoptose. Can you see it, Michelle?
Yeah.
So your white blood cells are unable to apoptose. So you'll see neurologic and muscular abnormalities or defects. And then you'll also see, often you'll see decreased Kell system expression.